So this was 110 sine 377 t. Okay, so what we have to do after that, we have to find the solution of this equation. Okay, so first of all, let's move towards the homogeneous solution. So for this, the characteristic equation will be 0.1 m square plus 11 m plus 100 is equal to 0. So to simplify this equation, m square, it will be 110 m, and then it will be 1000, okay, is equal to 0. So if there is any factorization, can we do 1000 and then it is 100, so it will be, if it is 100 times 10, that is 110. So yeah, we can do a factorization. So it will be 10m plus 100m plus 1000. So if you multiply 100 with 1, then you get 1000. If you add 100 with 10, then you get 110. So m into 10 plus 100 m into plus 10. So from here I get two factors, m plus 100 and m plus 10 equal to 0. So m is equal to minus 100 m1 and m2 is equal to minus 10. So the homogeneous general solution would be C1 e power minus 10t plus C2 e power minus 100t, or you can even say C1 e power minus 100t plus C2 e power minus 10t. That's also okay. So for C1 and C2 we need to find later on, but let's find the particular solution. Okay, so for the particular solution, then we need to apply the method of the undetermined coefficients. So let's assume the particular solution. In this case, it will be like this: a cosine 377t plus b sine 377t. Okay, so in this case, y prime will be 377 minus a sine 377t plus 377b cosine 377t. Okay, and then yp double prime is equal to it will be minus 377 square cosine 377t plus 300, and then it will be minus again. (377 square) b, here it will be a cosine 377t. We can apply this method of the undetermined coefficients. I will not show the whole procedure over here. I will just write down the answer. I will separately calculate it. In fact, we have done it several times before, so I don't want to spend some time of this video to these calculations. So we will find out the values of a and b as follows. I will just write down the answers. So by method of undetermined coefficients, a will be equal to minus 2.71 and b is equal to 0.796. So the general solution is C1 cosine C1 e power minus 10t e power minus 10t plus C2 e power minus 100t minus 2.71 cosine 377t plus 0.796 sine 377t. So these two coefficients C1 and C2 can be found by applying the initial value condition. So the initial conditions are given in the statement of the problem here. Assume that the current and capacitor charge are 0 when t is equal to 0. So current is 0 at t is equal to 0, and also the charge is 0 at t is equal to 0. Okay, so initial one of the condition is I 0 is 0. Okay, so in fact we have what we have found is I. So maybe I should better write it as I. I of t. So I0 is 0, and the other is that the charge at 0 is 0. Okay, so let's apply the first condition into this. So 0, and then this term will be C1, and then that term will be C2 because both will be 1, and then this term will be minus 2.71 because this will be 1 and that term will be 0. So we will get one equation C1 plus C2 is equal to 2.71. Okay, so in order to apply for this second equation, in which this the initial value is given in terms of the charge but not the current, we can go back to the very basic equation for the Kirchhoff's voltage law. Was that because the it was that the voltage across the inductance plus voltage across the resistor plus voltage across the capacitance was equal to the electromotive force, which in this case we take as this. Okay, and VL initially we found we said that VL is the inductance. Inductance was equal to L I prime, okay, di over dt, and VR was Ri, and Vc was Q over C, okay, the charge over capacitance, E naught sine omega t. So now in this here we can apply these the condition for the 0 charge at time is equal to 0. So therefore this will be L, and I prime we don't know actually, I prime of 0, so we can apply, and this is I prime of at time 0, we don't know actually, R, and then this is I, the current at time 0, which was already given in the first equation, first condition, so that is 0. Okay, so R is times 0, so this term will be 0, and then it is already given that the charge at initial time was 0, so this term will be also 0 divided by C. So from here, and then of course time was 0, sine term will be 0, so this will be 0. So this will give us as I prime of 0, that means the change in current at time 0 will be 0. So we can apply now this equation, this condition into our solution. So we need to take the derivative of that. Okay, so let's apply it. Let's take this derivative. So I prime of t will be then equal to minus 10 C1 e power minus 10t plus it will be minus 100 C2. Okay, it will be minus 100 C2 e power minus 100t, and then it will be plus 2.77 times 377 sine 377t, and then it will be plus 0.796 into cosine of 377t. So here I apply these values. So I prime of 0 now is 0, and then this term will be minus 10c1, and the second term will be now minus 100c2, and this term will be 0, and then this term will be then 0.796 times 372. Okay, 377. So plus 0.796 times 377. So I will not do this. So now I will get a second equation for C1 and C2. So I have this equation and I have this equation. I will not show you the solution of these two. I mean how I solve these two solutions. I will just tell you after this. You will get the answer as C1 is equal to. So C1 will be minus 0.323 and C2 will be 3.033. So with some rounding, maybe the answer may be a little bit different, but not much. Okay, so approximately we will get the same answer. Okay, so therefore the final solution is I of t is equal to minus 0.323 e power minus 10t and plus 3.033 e power minus 100t, and then minus 2.71 cosine of 377t and plus 0.796 into sine of 377t. So in this case we can see that we also have these two types of solutions. So the first two terms are decreasing in exponentially, and the other two terms are periodically changing. So we have a transient solution and this steady state part of both curves in this case. Okay, so that completes the topic of the RLC circuit. So you should solve some more numerical problems, and then you will be able to better understand this topic. So specifically speaking, these modeling examples are much same mathematically as was the solution for our second order non-homogeneous or even homogeneous differential equations with constant coefficients.